All right, today we're opening a case file that spans, just about 100 million miles. The location? Mars. The evidence? A really peculiar piece of rock. And the big question? Could it be holding the secrets to ancient life? We're diving into an absolutely fascinating new paper on the Perseverance rover's findings. And trust me, it reads like a cosmic detective story. And that's really the heart of it, isn't it? This new evidence forces us to ask this massive question. It's one of the biggest questions humanity has ever had. And the answer? Well, it might just be sealed up in a tiny tube, sitting on Mars, just waiting for a ride home. So the whole investigation really zeroes in on these tiny, unusual spots found inside a very specific kind of rock. Now, at first glance, you might think they don't look like much. But to a scientist, they're like a giant, blinking neon sign, a major clue that something really, really interesting happened right here, billions of years ago. Okay, so let's get our bearings. We've got to understand the scene of the crime, where these clues were found, and exactly why this particular spot on Mars is so incredibly important. So the scene is this spot called the Bright Angel Formation, right there in Jezero Crater. And the rover found this amazing combination of clues in the mudstone. First, we know it formed in water, which is, essential for life. Second, it's covered in these weird little nodules and dark-rimmed spots that scientists are calling leopard spots. And here's the kicker. The rover's instruments detected organic matter, the very building blocks of life, right there inside the rock. So how in the world do you conduct a forensic investigation on another planet? Well, the short answer is you can't. So you send the next best thing. A highly advanced robotic geologist armed with a whole suite of cutting-edge tools. Let's take a look at this super meticulous process that Perseverance uses. This isn't just a point-and-shoot kind of operation. It is a super painstaking, multi-step process. First, the science team back on Earth spots a rock that looks promising. Then, the rover's arm uses this abrading tool to literally grind off the top layer, kind of like a dentist cleaning a tooth, right? To get to the fresh, untouched rock underneath. And only then do the specialized instruments get to work, scanning all the chemistry and texture before beaming that precious data all the way back to Earth. It's an incredibly rigorous review process. So, meet the first of our star detectives, Sherlock. And yeah, that's its real name. Its specialty is hunting for organic matter. It shines a deep UV laser on the rock, and that lets it identify the specific chemical signatures of organics. It's the instrument that gave us that first aha moment when it confirmed those crucial building blocks were in the Bright Angel mudstone. And here's its partner, Pixel. Now, while Sherlock is off finding the organics, Pixel is busy mapping out the entire neighborhood around them. It uses X-rays to build this incredibly detailed elemental map, telling scientists exactly what minerals are there and how they're all arranged. You can think of it as creating a perfect chemical fingerprint of the crime scene. So, with our forensic tools in place and doing their thing, what did they actually find? This is where the case gets really compelling. Because it's not just about what they found, it's about how it was all arranged together. Pixel's analysis turned up two key minerals, vivianite, which is an iron phosphate, and greigite, an iron sulfide. But here's the absolutely crucial point. They weren't just scattered around randomly. They were physically tightly linked to the organic matter that Sherlock found. This whole setup points to a specific chemical process, a redox reaction, where the organic matter could have fueled a change in the minerals around it. And what's so wild is that's a process some ancient microbes right here on Earth used to get energy. This discovery, well, it leads us to a huge fork in the road. It's the central debate of this entire investigation. We've basically got two main suspects, two possible explanations for how these minerals and organics ended up this way. Okay, so on one hand, you have simple, lifeless chemistry. Maybe some organic matter that hitched a ride on a meteorite just reacted with some minerals in the water. That's the baseline theory, what scientists call the null hypothesis. But the other possibility is way more profound, that ancient Martian microbes were actually eating the organics and breathing iron and sulfate, just like some early life did here on Earth. And if that's the case, these minerals aren't just random byproducts, they're the fossilized waste from an ancient metabolism. The fact that all the evidence so neatly fits this second biological story, that's what makes this a landmark moment for astrobiology. This whole discovery is elevated from just a curiosity to something way, way more significant. So, the scientists have officially classified this as a potential biosignature. And believe me, that is a very carefully chosen term. It is not proof of life. What it means is that the feature is so consistent with a biological process that it basically challenges researchers to prove that it isn't life. It's a scientific call to action, saying, hey, the evidence here is just too good to ignore. So let's be perfectly crystal clear on this. The rover has not found definitive proof of ancient life. What it has found is a set of clues, the organics, the minerals, and their specific arrangement, that perfectly mirrors a known biological process from early Earth. The story fits like a glove, but the case isn't closed. Not yet. So how do we close this case? How do we finally figure out if we're looking at simple geology or ancient biology? Well, the answer, thrillingly, is already waiting for us. This is where the sheer genius and foresight of the mission just shines. See, Perseverance didn't just analyze this rock, it drilled into it and collected a perfect, pristine core sample. Its name is Sapphire Canyon. It's only about the size of a piece of chalk, but it contains everything. The leopard spots, the minerals, the organics. It is the key piece of evidence, all sealed up and just waiting. So what's the path to a final verdict? Well, right now, Sapphire Canyon is sitting on the surface of Mars. The plan is for the Mars Sample Return mission to launch later this decade, go get it, and bring it home sometime in the early 2030s. Once it's here, it can be analyzed by labs with instruments so powerful and so complex you could never, ever send them to Mars. And just think about that for a second. All of this, the rover, this multi-billion-dollar mission, decades of research, it could all come down to what we find inside this one single piece of Martian rock. The stakes? They just couldn't be any higher. So let's just end on this thought. If, in a decade or so, the labs on Earth analyze Sapphire Canyon and the verdict comes back, biological, what happens then? I mean, a positive discovery would mean that life started on two different planets, right next to each other, almost independently. It would suggest that the universe isn't just full of stars and planets, but that it's probably teeming with life. It wouldn't just change science, it would change philosophy, religion, our fundamental understanding of our place in the cosmos. All of that from a few strange spots in an ancient Martian mudstone.